Cade-Cole's Shake Table Lab. As we are drawing up our plans, we are also thinking of new designs that will work. We have started our base and structural supports of the bottom layer. We have now finished our first floor, and we are working on our second. Our strongest parts were the first floor supports that connected to the second floor. This helped a lot because our second floor wasn't so strong, so we had something to depend on. As we are finishing our tower, we are adding small details to increase the structural stability. We have used string very wisely in this project. We have used it for strengthening, endurance, and holding the sandbags. When we finish our tower, we added extra supports and tape to the bottom to keep it on the cardboard. We also added a final barrier for the sandbags so they wouldn't fall off. We had lots of plausible designs, but we picked our favorite and the most successful. Our first floor was 19 centimeters tall with 25 different connection points. Our top floor was 20 centimeters tall with 18 different connection points.
It is a very good, very good.
Our weakest part was the barrier at the top because we had no straws left and we had very little to reinforce it.
Our tower failed in the first floor, where many straws failed and came undone. As you can see, these straws right there and there are broken off.
Our sensor readings on the x-axis is the strongest axis used for this project. The x-axis shook so much because our tower shook at the top. The x-axis is the bottom green line on the readings. We used our string for many different things, including flooring and tying down the sandbags. Our tape was used also in many different ways. It was used as in securing the tower to the table and securing the straws together. If we had extra supplies, we would have used them to make the second floor much more stable. So our building held 2 extra sandbags along with the original 4, and it failed along the side when part of it was leaning over, and so one of the pieces snapped out, making it fall. If we would build it over, I would probably use X's, and I would make the top floor and the bottom floor of the building curve in more, so it would provide more support, making the weight go out into a larger area. And so, what I learned about earthquake-proof buildings is that you need to make them so they're really wide at the base, and then they thin up towards the top so that they're rigid. But if they're extremely tall, you want them to be able to sway back and forth, so you would use something bendable like that. And so probably my favorite part about this lab was definitely watching other people's buildings fall and being able to build our own with tape and other resources.
Extra sandbags other than the original 4. So we had 105 points overall. Our building failed in the top floor, along the supporters, along the sides. If I were going to build it over, I would rebuild the first floor and have X's rather than the V's we made. I learned that it's good to be a little different, but it's really important if you were to have X's or triangles inside. I like just working on it and trying to figure out how we were going to construct this thing and how we were going to use our supplies wisely. And it was also funny to watch other buildings just crash.